Hello students, I am here to explain the static implementation of stack data structure means implementing stack with the help of array. You know array is what? Array is a collection of same data type elements and array elements are stored contiguously inside a memory. We can access array elements with the help of index. Okay, now what is this stack? Stack is data structure. It is a linear data structure which follows last in first out approach. Means see, this is just a diagrammatic representation of a stack data structure. Here there is only one end called as the top of the stack. Means from that one end only you can insert element into the stack, and from that one end only you can remove the element. Now see here, whatever element you are inserting, that operation is nothing but a push operation, and if you are removing any element, that is called as a pop operation. See, inserting element into the stack, that is called as a push operation, and removal of element from the stack, that is called as a pop operation. And suppose you are just displaying all the elements of the stack, that is nothing but a display operation. Again you can call it as a show. There is one more operation, that is peek operation, means just displaying the topmost element without removal of it. Now suppose I am just inserting some elements into the stack using push. Like 5 elements suppose we have inserted. Initially whenever there is no element, then that is called as a empty stack, stack underflow. Okay, and suppose you are inserting some elements, like suppose you have inserted 5, then this is now top. Okay, now suppose I am inserting one more element into the stack, let it is 10, then now this one will be the top element. And if you want to remove the element from the stack, then only topmost element you can remove. Like this 10 element only you can remove. You cannot directly remove 5. To remove 5 you have to first remove 10, then 5. Whenever you will call pop, automatically the topmost element will get removed from the stack, and after that top will become 5. Okay, and display means you are just displaying all the elements from top to bottom. This is display operation. Now here I am just going to implement this stack data structure with the help of array concept. Now how to do that? See, here we will consider one array like this. Okay, and array capacity will be max. Here you can declare array of size 10, 5, 20, 50, anything. Okay, now currently this is 50, means 50 elements you can insert into the stack. Getting? Here we have created array of size, see, stk of max. What is this? This is nothing but a array. Name of array is stk and its size is 50. With the help of this array we have to just implement all the operations of stack, like push, pop and display. Getting? And for that we have just declared here array like stk, that is stack. I am calling here stack of max. Max means here size of that array is 50. Here we have declared one constant max with 50 value. Getting? Now next one is top is equal to -1. Whenever there is nothing in that array, means array is empty, stack is empty, then at that point top we have to set to -1. Okay, why is -1? Because array index starts with 0, then 1, then 2 and so on up to here, in this case up to 49. Getting? Now array index starts with 0 and ends with size -1, means if there is any element at the place of 0, means that stack is having one element, and in that case top will be 0. Getting? See here array index is nothing but 0 to size -1, that is 0 to 49, and topmost element, top is a variable. Here we have declared top will be always holding the index of topmost element. Getting? Means here we have to just insert element one by one and we have to maintain the top index. Top will hold the index of topmost element. Here consider stack like this, in this way. This is a stack. Okay, in this way, see, this is 0 index, this is 1 index, this is 2 index up to 49. In this way the stack will be, and top will have the index of the topmost element always. Now currently initially we have to just assign -1 value to top whenever there is nothing inside that stack. Whenever we insert any element, that index will be the value of top. Getting? Now see, first operation is push operation, means currently see initially top is -1. whenever we do push means we are just inserting element into the stack. Now how to insert element? We have to just increment the value of that top index. Getting why? Because see here at this place at 0th index we will insert the element. That's why top we have to increment first, and at that place we have to just place whatever element to be pushed. And before that we have to check whether that stack is full. If it is full, then we cannot insert any more element. Means if suppose top is 49 means max minus 1, then here there is a element, then no more element you can insert in that stack. That's why we have to check like this. If top is equal to max minus 1 means here we can definitely say that stack is full, means stack overflow. Here we have to just print f stack overflow. Getting? Otherwise we have to just increment the top first, means the top will become 0 and at that place element will get inserted. Suppose currently there are some elements, suppose 0th and first place means 2 elements are there in that stack. Again we have to increment the stack, means at second place we have to insert the elements, means every time we have to increment first top and then at that place we will insert the value. Means top equal to top plus 1 first we have to do, and at that place in that array we have to just place the element. But see, before that we have to accept the element from user. Here we have not passed argument. We have not passed argument to that push function. You can pass argument or you can accept here also. Okay, see, we will declare one more variable here n to accept that value, okay, from user. See, first we will just give message to the user like printf enter that number, enter number, okay, in this way, and just scanf that number first, like scanf %d suppose comma ampersand n. Now that n element we have to push into the stack. First just increment the top. Here you can write top equal to top plus 1 or top plus plus, both are same, and at that top place we have to insert the element in this stack, like stk of top is equal to that element, that is n. Getting? This is just a push operation. And now before explaining other functions, I am just explaining first this main function. See, inside main what we have done, we have just declare one ch variable is for choice, means whenever you are doing any program for implementation of data structure, in that case what you have to do, you have to just give options to the user, like what operations you want to perform onto the stack. That list you have to provide to the user with option, means suppose first option is push, then second one is pop, then third one is display, and fourth one is exit. In this way option or menu you have to provide to user, then user will enter any option like push, then push operation you have to do. Second, suppose user is pressing 4 option like exit, then you have to stop that process. In this way we have to do. That's why menu driven program is needed in case of data structures. Second thing is, here you have to use loop concept like while loop. While loop, why? Because here we have to repeat those menus until user is pressing that exit option. Means suppose initially user want to do push, again second time push, again third time push, again pop, then display. Everything should be done repeatedly again and again. That's why here we have to place a while loop in a finite loop, okay, or till user is not pressing that exit option. Getting? Now see what we have done here. See, this push, pop and display, these are just the function declarations. These 3 functions we are going to write for 3 operations. Now in main, first ch variable we have declared, that is for choice, then I and j. See what is the use of I and j, that we will use later. Next one is, see, choice is not equal to 4, means still user is not entering choice as a 4. We have to repeat this loop again and again. Next one is here, see, till choice is not 4, this menu will be again and again displayed to the user, and whatever choice, on the basis of that operation is called here. That function has been called here according to the choice. Now see here, first option is push, then pop, then display, then exit. These all options are displayed here with the help of printf. First that list will be displayed onto the output screen. Then next message will get displayed like enter your choice. Suppose user is entering choice as a 3. Then switch CH. Switch means what? From that CH, whatever value that will be checked with all these cases. Whatever value will be matched, that case will be executed. Getting printf exiting, then here we have to place break actually. Okay, now suppose user has entered one choice, then here push will be called, and break means it will come out of that choice. Okay, means after again the same thing will be repeated, same while loop. Suppose next choice is not equal to 4. Yes, of course it is not equal to 4. Choice is currently 1. Again that menu will be displayed. Again enter your choice option will be displayed. Then again suppose user is entering choice as a 2. Then pop function will be called. That we have to write now. We have just written push function. Next, after that break. Again the loop will be executed. Now again suppose user has entered. See, initially ch value is 0. That's why we are coming inside that loop. Okay, otherwise while 1 also you can place here, infinite loop, that is again okay. But here break is not sufficient at the place of case 4. In that case we have to place exit 0, means come out of the program directly. Okay, now see here again choice will be displayed. Suppose user is entering choice as a 4, then exiting message will be displayed, and break currently choice is 4. That's why we are coming out of that while also. Getting? Means this is the way you can write programs for data structures like a menu driven program. Getting? Now see, push operation I have already discussed. Now how to do pop operation. For that, see, suppose this is a stack. Currently we have push suppose 2, 4 and 9 element, and top will be now 2. Okay, consider stack like this, means topmost element is the last element inserted, and top will hold the index of last element inserted. Stack follows last in first out, means if we will call pop, means at that point the 9 should be removed. Okay, but actually we are not removing 9. We will just change the index of top to the 1, and we will just display the popped element as a 9, and now that will be considered as a garbage value after that. Okay, now see here pop operation how to write. First we have to check whether stack is empty or not. If it is empty, then we have to just display their message like stack underflow. In that case we cannot pop any element. That's why here we will check stack empty, means top is -1, suppose, means there is no any element in the stack. In that case we can say that stack is empty. Like if top is equal to -1, then we have to just display like printf stack underflow. Getting? Otherwise, means if top is not equal to -1, means at least one element is there. Okay, that we can remove now. In that case what we have to do, we have to just display first like popped element is %d, comma, here from that stack the topmost element like stack of top. Okay, and now we have to just decrement the top like top minus minus. Getting? Means first we have checked whether stack is underflow. If it is not, then else. Okay, else will be executed in that case. And their popped element is %d stk of top. Stk of top means from that array name is stk, top element index, top is holding index of topmost element, means stk of 2 is 9. Popped element is 9, that type of message will be displayed. And now we have to just decrement the top. Now top will become 1. Why? Because we have removed this element. Getting? Means here actually we are not removing, but that will be now considered as a garbage value. Whenever you will push again any more element, then on that 9 the next element will get replaced. Getting? This is a pop operation. And now the last one is display operation. How to do that? See, in case of display, again you have to check whether that stack is empty or not. If it is empty, then you cannot display the element. Otherwise what we have to do, from top index, now see currently suppose top is 2. Okay, from top index we have to just go in reverse order up to 0 and display all the elements one by one. How we can place their for loop, like for I is equal to, here I have used I, okay, j is not required here. See, I is equal to top, from top we have to start. I greater than equal to 0 means up to 0, and I minus minus we have to just display all the elements one by one, like printf %d, and after that I am putting slash n. Okay, slash n means go to new line, and then from that stack means that array ith element I will become, I is initially top, and after that it will be decreased by 1 1 1 up to 0. Getting means first second index element will be displayed like 9, then 4, then 2. Getting, in this way we can place a for loop to display all the elements of stack. Here we have to display the array in reverse order. Getting, this is just a logic for display function. Now here on the basis of choice whatever user is entering, that function will be called. Getting, first we have just discussed about push, then pop, then now it is display. This is the static implementation of stack, or implementation of stack with the help of array. In the next session, we will discuss one more important question in data structure. Till that, take care. Bye-bye. Thank you.